Alright, now I'm going to try to convince you that these formulas are true, or at least I'll convince you that S1 is true. And then you'll have to take my word for it that S2 and S3 are true. And I also want to show you how to use the formulas. Alright, so first let's talk about how to use, and then we'll talk about why this one's true. Okay, and S1, that's just a way to label which formula I'm talking about. Okay, so this is kind of bad notation here. The better notation for this would be something like this: I equals 1 to n I. But you're not going to learn this until Calc 2, and I don't want to spend too much time on it, so we're going to use this notation here. Once you understand what this notation means, everything will be fine. Okay, so what this is saying is, if you just have 1 is equal to 1 squared over 2 plus 1 over 2. You can see that this is true because 1 squared is 1, 1/2 plus 1/2 is 1. Okay, this does not mean when you plug n. Okay, so if n equals 1, then this is what it's saying. A common mistake is for students to say, "Oh, okay, this means 1 plus 2 plus 3 plus 1." Does not mean that. This is why it's kind of confusing at the beginning. Okay, n equals 2. This means 1 plus 2 is equal to 2 squared over 2 plus 2 over 2. Let's just verify that this is correct. Let's see. 2 squared is 4. 4 over 2 is 2. You can see that this is 3. That's 3. Okay. It does not mean 1 plus 2 plus 3 plus 2. It literally just means that. N equals 3, this says 1 plus 2 plus 3 is, follow the formula, we went up to n, it's 3 squared over 2 plus 3 over 2. And let's just check that this is correct. Okay, so right now we're not sure, so I put a little question mark there. Let's see, 3, 4, 5, 6, we got 6 on this side. This side we got 9 over 2 plus 3 over 2. Well, let's see. 9 over 2 plus 3 over 2, that's 12 over 2, which is 6. Okay, so you can see that in fact it's true. Okay, so now let's say that n equals 10. Let's say n equals 10. What this gives is a nice little formula for adding up the numbers 1 through 10. 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7 plus 8 plus 9 plus 10. You could just add all those up and figure it out. You could, but this formula tells us that adding this up, see we added up to 10. This is 10 squared over 2 plus 10 over 2. Let's see, that's 100 over 2 plus 10 over 2. Let's see, 100 over 2, that's 50. And plus 5 is 55. So the formula just gives us a nice way to add all these guys up. You might say, hey, I don't believe you. I don't believe you that when you add all these up you get 55. So maybe you should just add them up. And then you will know that it does equal 55. But let me show you another way you could do this. Let's see. You could rearrange it. 1 plus 10 plus 2 plus 9 plus 3 plus 8 plus 4 plus 7 plus 5 plus 6. This is 11. plus 11 plus 11 plus, so that's that 11, 11, 11, 11 plus 11. And now you've got 11 added to itself 5 times. This is 5 times 11. Or 11 times 5, I guess really is what that is, but you know that's the same. Right, when you write 11 times 5, this is really what you mean. The definition of multiplication is repeated addition. So 11 times 5 is 11 added to itself 5 times. We know that's 55. Okay, so I've convinced you that it works for 10. At this point you're probably totally convinced, but still I'll convince you that it works always. In other words, I'll give a, you don't want to say the P word too often in a math class. Students will freak out. Okay, all right, so let me prove this, okay? So the way we'll prove this is you say S equals 1 plus 2 plus 3 plus n. Okay, so I'm going to prove that this is true here. So I just say that S is equal to adding up all the numbers 1 through n. Oh, okay, all right. I apologize. I should probably say, okay. So now let's see. All right, let's add up to, we're going to add up to n. Right, so then what is the number that comes before n? Aha, it's n minus 1. And what's the number that comes before n minus 1? N minus 2. Good. Okay, now let's write it all backwards. We got n plus no, you will not have to do this on a test. Okay, adding them up, let's see. S plus S, that's 2s. This is n plus 1. This is n minus 1 plus 2. Let's see. N minus 1 plus 2. That's n plus 1. Plus n plus 1 plus, here, n minus 2 plus 3. That's n plus 1. Let's see, how many n plus 1s do we have there? Let's see, we have a counter actually. We have 1 of them, 2 of them, 3 of them, to n of them. So here we have n plus 1 added to itself n times. Now we want to solve for s. So divide both sides by 2. We have that s is equal to n plus 1 times n over 2. Now lastly, n plus 1 times n over 2. This is distributing that n. We got n squared plus n over 2, which is n squared over 2 plus n over 2. So I have now proved that s is equal to that. We started with saying s is equal to that, so now we know that this guy is equal to s, which is equal to that. And that proves the formula. Now for the other two formulas, S2 and S3, if you're interested in proofs of those things, then either you're a math major or a computer science major or something. And you can take Math 187 or Math 189, and you will prove these using mathematical induction. All right. If you're like, oh my gosh, then don't worry about it. It's okay. If you're like, oh my gosh, but that's so cool, you can do this.